Okay, for this video, we'll be going through the WA3 practice paper set 2.2. Okay, so you should see the first MCQ looking like this. Right, a block of wood of mass 4 kg, so always annotate this is my M, with an acceleration of 0.8 meter per second square, so this is my A. And you might also now start to think that whenever there is acceleration, there is going to be F net. Okay, so this block of wood actually has an acceleration of 0.8 meter per second square when it is pulled along a rough surface. That means there's going to be friction. Okay, and it is pulled with a force of 15 newtons. So if I'm pulling the block with a 15 newton force to the left, the frictional force will be to the right. Okay, so I can actually over here draw my free body diagram. Alright, it really takes just a short while. Let me have the friction force, and then I have my 15 newtons here. Okay, so and not forgetting that I have acceleration. So if I have acceleration, I'm going to have F net. The other way of thinking is whenever I have F net, I'm going to have acceleration. Okay, so let us calculate the F net. The mass is 4. Please check that this is in SI unit. Okay, sometimes I might give the mass as 400 grams, 20 grams even. Okay, so always check that it's in SI unit of kg. So my acceleration is 0.8. So 4 times 0.8 will be 3.2 newtons. That means I am going to have an F net. This is how you represent the F net. It should not be touching the object. It should be above, and it should be represented with a double arrow to show that it is an F net. So my F net is actually 3.2 newton. Very strange, because I'm pulling with 15 newton. However, the F net that I get is only 3.2 newton. That means my friction must be 15 minus 3.2, because this friction is opposing my motion. So I'll get 11.8 newtons. Okay, so this is my frictional force when it's being pulled on this rough surface. Now, what is the acceleration of the block at the instance when the 15 newton force is removed? So suddenly I remove this. So now I draw my free body diagram again. And because the 15 newton has been removed, I don't include this in my free body diagram. So that makes the friction force the only force that is acting on this 4 kg. That means my 11.8 is actually now my F net. So imagine if I have F net, not imagine, every time I have F net, okay, I am going to have acceleration. So my F net is 18.2, my mass remains the same, so my acceleration is actually 11.8 divided by 4, it is actually 2.95, but because it is opposing the motion is still going this way, right? Even after I have removed my 15 newton pulling force, it will not stop immediately, right? It will decelerate. So they are asking for the acceleration is actually to the block, it is actually decelerating. But since there's no negative deceleration, A will be the answer, because they're asking for acceleration. Negative acceleration, right? If it's in the opposite direction, it is equal to deceleration. Okay, question 2. A parachutist falls in air, attains a constant speed. So this constant speed tells me that there is no F net. Okay, so these are the things that when you read, you must annotate down. He then opens his parachute and decelerates. The purpose of opening parachute is to increase surface area so as to increase your air resistance. Okay, so he opens his parachute and decelerates while the parachute is fully open. He eventually falls toward the ground at a smaller constant speed. So again, no F net. Okay, so we have 2 periods whereby he doesn't have F net. Now, which of following stage correctly describes the upward force acting on the parachutist in each stage? Okay, so maybe I will need to draw a free body diagram. Okay, so when he's falling, in the first part, he obtains constant speed, no F net. So the downward force is weight, and this is his air resistance. Okay, so they are asking for the upward force, right? So there must be upward force because there's air resistance. So it cannot be A. So it's either B, C, or D. Okay, and that is the first stage. Next, he then decelerate when the parachute is fully open. How did he decelerate? By increasing the surface area, so something like that. Alright, that means the air resistance, which is the upward force, must be higher than before, and that will mean it is C. Okay, because this is incorrect, this is incorrect. But how come this happens? Okay, now as you know, looking at this free body diagram, F net is upwards, but his motion is downwards. This F net is actually the air resistance minus the weight. Throughout his fall, the weight remains the same. But because he opens parachute, his air resistance increased. So now F net, before that F net was 0 because it was moving at constant velocity. Okay, but now because he opened parachute, air resistance is upwards, therefore F net is now upwards. Okay, so if F net is upwards but motion is downwards, he will decelerate because it's in the opposite direction. Okay, I think we have similar question in practice paper set 1 and 2.1. So actually he will decelerate because his motion is downwards but F net is upwards, right? So if he decelerate, it will bring about a decrease in the air resistance. Alright, so next moment, the air resistance starts to be lesser than before. Okay, and when air resistance decrease, your F net will also decrease. The F net upwards is still bigger than your weight, but the value is smaller than before, smaller. Okay, and when F net is lesser, okay, he will decelerate still. He will decelerate still, and his speed will decrease. Speed decreases, and air resistance will still decrease. So eventually, the air resistance decrease until again it is equal to W. But his speed has already decreased, so he actually ended up with a smaller speed. Okay, so that's why we see that the upward force, which is the air resistance, decreases. Okay, I think I'm not very smooth in my delivery, so you may want to rewind and watch it again. Alright, okay, so the important thing here is draw your free body diagram. Okay, I think I emphasize this in all my videos when we are dealing with forces. It will help you visualize how the forces are acting, and most importantly, you will get your F net from there. Okay. Okay, question 3. It shows a hydraulic system where the cross-sectional area is 12. So I will say AM, which is area of master. The slave is AS. Okay, and we take note that they give us area, so there's no trick to that. If I were to give you radius or diameter, please be careful. Okay, because of pi r square. Now 60 Newton force is applied to the master, so can I put this as Fm equals to 60? Okay, now what is the force experienced by the slave piston and the pressure experienced by the slave cylinder? So pressure equals to force over area. So because of the hydraulic press Bernoulli's principle, pressure experienced at master will be equal to the pressure experienced at the slave. That means I can convert this to Fm over Am equals to Fs over As. And we have all this information. We have Fm, we have Am, we have As, but not Fs. So let me calculate what is Fs. Fs equals to Fm over Am multiplied by As. Fm is 60. Am is 12 multiplied by 8. So Fs is actually 40 Newton. Okay, that means the force at slave cylinder is 40. How about pressure? Take note that for this question, I'm very kind to just leave it in Newton per cm square. By right, if I were to ask you to express it in Pascal, you need to convert your cm square into meter square, because everything has to be in SI unit. So pressure equals to force over area. So I can calculate the force at Fm over Am. Okay, it will be Fm is 60, Am is 12, so it will be 5. Okay, or I can calculate the pressure at slave. So Fs, what I've calculated is 40 over 8. It still gives me a pressure of 5 Newton per cm square. Why? Because of Bernoulli's principle. That's why it's being applied in our hydraulic system, whereby the pressure is the same. So answer will be C. Okay. Okay, now this question, a length h of mercury of density rho is contained in a test tube inclined at an angle theta to the vertical. The test tube has a cross-sectional area. Okay, you know that cross-sectional area doesn't play a part in the measurement of the PATM. Okay, doesn't, right? Because the pressure is determined by rho GH. Okay, so you don't see any area inside, it doesn't play a part. Okay, so it is independent of A. Okay, you have your H, you have your theta. By right, we cannot do this H. We have to get the vertical height. That's why we need this theta as well. Alright. Okay, next is a structured question, whereby the first one is to draw vector diagram. Okay, so for this vector diagram, for vector diagram, basically you just need to make sure that they are tip to tail. Okay, so the tip for 200 Newton is here. The tip for 350 Newton is here. So now they are arranged in a tip to tip, which I don't want. I need tip to tail. Okay, I need tip to tail. So I can either shift my 350 Newton. Let me give it a different color. 350 Newton. I shift it here. Okay, so when I shift, I must make sure that I keep to this direction by using this angle. So if over here is 60 degrees, I can measure here and get 60 degrees. So with this, okay, now my vector diagram looks like this. 200 Newton, I did not shift it. Okay, but my 350 Newton, it will look like this. Okay, so of course you must draw with the correct scale. So do you notice that the black color arrow, the tip is touching the tail of the 350 green arrow. So now we have gotten our tip to tail. Okay, so we actually don't need to care about this anymore, because once you have shifted it correctly, the original 350, you can ignore it. Alright, that means you can erase all this, and this is actually the start point, right? This is the end. This is the where we start, and this is where we end, right? So if I were to ask you to walk this way, you will say, why don't we just go directly from start to end, and that will be our resultant force. Okay, so this one is pretty simple as long as you just go to tip to tail. The more difficult one is when there is when three forces are in equilibrium. Okay, how do I know that they are in equilibrium? They will tell me it is either in equilibrium or stationary. Okay, so in this case, there will be no F net, no resultant force, because these three forces actually balance each other. But if you look at this, these two forces, they only will result in a resultant force. Okay, so you must know how to draw this. Okay, question 2, it shows a steel ball bearing falling from rest. So this is important. So U is 0, initial speed is 0, through a tube of oil. So forces W and U act on the steel ball bearing. W is the weight, while U is the upward force. Okay, so it comprises the up thrust, that means it's thrusting it up, and the friction of oil. Upthrust is measured by the weight of oil displaced by the ball bearing. The distance time graph represents the motion of the ball bearing as it falls through the oil. Okay, this doesn't look properly, so I have the picture captured here. Now they want us to explain in terms of the forces W and U why the ball bearing accelerates at first, then falls at constant speed. So I will need to draw a free body diagram. Okay, so this is the ball bearing. Initially, okay, it has weight. Yeah, it always has weight. Okay, and it was initially released at the start. Okay, so at first, when it first fall, okay, the oil resistance is low. Okay, the oil resistance is low, right? Oil resistance is low, so the upward force is low. The upthrust is lesser than the weight. So there is F net. There's F net. Okay, so it will cause it to accelerate, because whenever there's a F net, there's going to be acceleration. Okay, so next stage, what happens when there's acceleration? The velocity will increase. Okay, we know that something when it's falling through air, as velocity of it falling down increases, the air resistance increases. Similarly in oil, when it's falling down in oil, okay, as its speed increases, the oil resistance will also increase. So next thing I want to draw is my U increasing. Okay, my U increasing. I try to make it such that it is a slightly longer arrow, so you can see the difference, although it's not very obvious. So now I will still have F net, but the F net will be lesser than previous. So maybe I call this F net 1 and I call this second case F net 2. So F net 1 is more than F net 2. Okay, so but still, if I have F net, I'm going to have acceleration. But because this one acceleration 1, this one acceleration 2. So because the F net is lesser, therefore the acceleration of 1 is greater than acceleration of 2. That means the acceleration has decreased. But you cannot say that the velocity decreased. Okay, acceleration is lesser than initially. Okay, that means acceleration has decreased. Right? Because the F net has decreased. But if the acceleration has decreased, it doesn't mean that the velocity decrease. It means that the velocity increases, right? Because acceleration tells me velocity increases at a decreasing rate. At a decreasing rate. Okay, so please be careful, because a lot of students initially during lesson when I ask them, hey, acceleration has decreased, they'll tell me, oh, velocity increases at a decreasing rate. But now I hear more and more students say, when acceleration decreases, the velocity decreases. No, it is not true. Okay, it's just that the velocity now increases at a smaller rate or lesser rate than before. And this is what you can see from the distance time graph. Look at this distance time graph. Distance time graph, what does it mean? The gradient represents speed. Okay, so initially the gradient here is gentle. Then along the way, it becomes steeper. So the gradient actually went from gentle to steep. That means the gradient increase. And what does gradient means in a distance time graph? The gradient represents speed. That means the speed increase. Okay, but however, we are not able to see whether is it increasing at a decreasing rate or constant rate or decreasing rate. Okay, we cannot see what is the rate that is increasing because this is not a VT graph. Okay, but from here I know that the speed has increased. That means there's acceleration. Okay, so but later on when we come to here, we find that the gradient is constant. Gradient is constant. If the gradient is constant, it means that the speed is constant. That means no acceleration, right? It's because as the acceleration increases, the speed increases, right? The oil resistance will increase. So now I'm going to draw the third diagram here. My weight is still the same. Now my U is equal and opposite. If it's equal and opposite to W, F net is 0. If F net is 0, that means no acceleration. Acceleration is 0, that means constant speed. Okay, so in your answer, when they are asking for explain in terms of forces, you need to talk about W and U and F net. Okay, let me show you the answer. Okay, so initially W greater than U, downward resultant force causes ball bearing to accelerate. Now as it accelerates, this is important, the oil resistance increases with increasing speed. When U increases until it equals to W, U is my upward thrust due to the up thrust and the oil resistance. The resultant force will equal to 0. So it will then fall with constant velocity. Okay. Okay, then now question 3. A 10 kg object, so this is my mass, is initially at rest, so the U is 0. On a horizontal surface, a horizontal force is then applied to the object for 25 seconds. Okay, how much is the force? It's 20 Newton, and then it drops to 8 Newton until 25 seconds, right? It shows how the force varies. If the object moves with an acceleration of 1.2, so I have acceleration. If I have acceleration, I'm going to have F net. So I'm going to do my calculation straight away. Because my mass is 10, my acceleration is 1.2. Therefore, it is 12 Newton. So my F net is 12. How do I represent this? This is 10 kg, right? My F net is 12 Newton, right? F net, you draw above the object. You don't touch the object with a double arrow. So this happens during the first 15 seconds. First 15 seconds, that means I should be using this amount of force, which is 20 Newton. That means I have 20 Newtons here. So, they asked us to calculate the resultant force, so I got it here already, 12 Newton. Okay, then they want us to calculate frictional force. You see, they are always asking for the same concept. Why is it that when I push with 20 Newton, I only get an F net of 12 Newton? It's because there must be an opposing force of 8 Newton, right? 20 minus 12 equals to 8. So now if I take 20 minus 8, I will get back 12, which is the F net, which when I feed into here, then I'll get an acceleration of 1.2 meter per second square. Everything needs to tally up. So the frictional force is 80 Newton, 8.0 Newton. Please leave your answer in either 2 or 3 SF. Now, assuming that the frictional force remains constant, so let me draw my free body diagram. My frictional force is 8 Newton, it remains constant. Describe the motion of the object during the interval from t equals to 15 to t equals to 25. I cannot stress the importance of free body diagram enough, right? Because if my free body diagram actually helps me to visualize and put down, okay, visually, what are the forces? So you see, from 15 to 25 seconds, the pushing force is now changed to 8 Newtons. So if I represent it in my free body diagram, I'm selling you this idea again. 8 Newtons and 8 Newton, they cancel each other. So F net equals to 0. If F net equals to 0, acceleration equals to 0, right? That means it will move with constant velocity. Why doesn't it stop? Because it was already moving. So this is how we explain the answer. Okay? So please draw your free body diagram. Let me see how many of you draw free body diagram during the WA exam. Okay, so at 15 seconds, pushing force reduced to 8 Newton, friction force remains at 8 Newton. Therefore, no resultant force, right? You can see very clearly from the free body diagram. Since the box was already moving, you'll move with constant velocity of 18 meter per second. How did I get 18 meter per second? Right, because A equals to V minus U over T, right? The acceleration at the initial state was 1.2. It was pushed for 15 seconds. Duration of 15. My final speed is what I'm trying to find. Initial speed is 0. Therefore, my V is 18 meter per second. Okay. So, how do I know that I need to do this calculation? Well, the better students would have all this information and they'll do a calculation. That's how the teachers know whether you have thought it through. Okay. Okay. Next question 4. Two ice skaters at rest on a smooth icy surface. Smooth, that means no friction. Okay. Where there is negligible friction, they emphasize this again. They are acted upon by the force of 200 Newton exerted by a third person, as shown in figure 4. The two ice skaters then move with an acceleration of 1.6. Both of them move with 1.6 because they are touching each other. Okay, so their acceleration is 1.6 meter per second square. The mass of A is 50 kg. Nice weight, nice mass. Okay, but B, I don't know. I don't know what's the mass. Mass of B is unknown. Mark on figure 4 the frictional force acted by the ground on the shoes of the third person. So this is the third person. Okay, if he is pushing, right? He's pushing, his feet should be rubbing against the ground. Okay, so the frictional force should be to the right because he's rubbing his feet. He's rubbing his feet, right? He's trying to push these two people, right? So his feet will be brushing on the floor. So I need y'all to actually try to brush your feet on the floor now. If you brush your feet to the floor, right, you will find that the floor is pushing you forward, and that is the frictional force. Okay, now they want us to calculate the mass of B. How do we do that? Okay, so we have to draw our free body diagram. Okay, so let us do A and B together because they are stuck together. Both of them get this pushing force of 200 Newton. Okay, and if we consider them as a whole system, their acceleration is 1.6 meter per second square. Now, whenever there's a acceleration, there's going to be F net. There's going to be F net. So how do we calculate F net? F net equals to MA. But we don't know what is F net. We don't know what's their combined mass, right? Their total mass. But we do know their acceleration is 1.6. But if you consider this AB as a whole system, are there any other forces acting on them? No, it's just this third person exerting 200 Newton. Is there any friction? There is no friction. So I can say that this 200 Newton is actually the F net. Okay? So you may say, how do I know? You really have to read. You really have to understand the context of the question. And most importantly, you need to draw your free body diagram. Okay? So if my F net is 200, my mass is this, M unknown, my acceleration is 1.6. With this calculation, my mass is going to be 125 kg. Okay, and that is the total mass of A and B. But since we know A's mass, okay, so I take 125 minus 50, I will get 75 kg. Okay. What is the force of A on B? Force of A on B, right? A on B, that means A push B. Okay, so if A pushes B, by Newton's third law, B pushes A. Okay, so now we have to draw free body diagram. So you see this practice paper, everything is about free body diagram. So you need to master your free body diagram. Okay, so previously we draw A and B together. Okay, it was acted upon by 200 newtons, remember? And there was an acceleration of 1.6 for both. Okay, so now we have to draw free body diagram for A and B. Okay, so the acceleration of 1.6 meters per second square will still apply to both of them. And since now I know their mass, 50 kg and 75 kg, okay, I can do some calculation, yeah? So for A, what is pushing her towards the right is actually the 200 newton by the third person. But when she when she's being pushed and she's touching B, she's pushing B, B is pushing her back. This is Newton's third law. You need to know this. Okay, so there is a force of B on A. Okay, FBA means force of B on A. Okay, why don't we draw the force of A on B? Why don't we draw FAB, which means the force of A on B? We don't draw this because, listen carefully, free body diagram shows all forces acting on the object. On the object, not by the object, on the object. It shows all the forces acting on the object. So A cannot be pushing herself. A is pushing B. But because I'm drawing the free body diagram of A, I will not draw the force that A acts on B on herself. Okay? But you know that when A pushes B, B is pushing A back. So I will have this force that B exerts on A, because free body diagram shows all forces acting on the object. Now come to B. Does this 200 Newton gets pushed onto B? I will say no. Okay, and I think I've used this example in class. Imagine you're at the front of a queue. Okay, you have a lot of classmates queuing to buy Western food. This last guy pushed the guy, and so on and so forth, so on and so forth. In the end, you got pushed. Will you run to the back and then scold this guy? No, you just turn around and say, hey, why you push me? The person behind you. Correct? So you wouldn't actually know that this guy started the pushing. So you only know that for B, A is acting on B. That's all. Right? He doesn't know that the guy at the back is pushing using a 200 Newton to push. So I will put FAB. FAB means force of A on B. And guess what? FBA and FAB, they are a pair of Newton's third law. Okay, Newton's third law states that the forces must be equal, right? They must be opposite in direction. Okay, they must be opposite in direction, and they must be the same kind of forces. Same kind of forces, and most importantly, act on opposite body. Okay, A push B, B push A, right? So you need to know this, very important for Newton's third law. Okay, so now, which free body diagram shall we act on? I will use this because it's very simple. There's only FAB, there's acceleration, there is a mass. Remember, F net equals to MA. Now I'm using B. The mass of B is 75, acceleration is 1.6. So with that, I can calculate it to be 120 newtons. And because FAB is the only force that's acting on B, the 200 Newton doesn't go there. Therefore, FAB is 120 Newton. Which then means that FBA is also 120 Newton. Can I prove it? Okay, let me redraw A. Free body diagram. All the forces acting on A. Now, because I know FBA is 120 Newton, I'll put it in. So these are the two forces acting on A. There's no friction, just the 200 Newton by the third person and 120 Newton by B on A. By B on A, because A is pushing B. Newton's third law. So can I calculate that the F net is 80 Newton? F net is 80 Newton, right? What's the mass of A? MA is 50 kg. Therefore, if I were to do a calculation, F net equals to MA, my acceleration is 1.6 meter per second square, right? So it tallies because I did not use this 1.6 until now just to check my answer. Okay, so please look at this question. It is very important, yeah? Okay? Okay, go to question 5. Okay, iron cube of side 3 cm, that means the volume and area can be calculated, has a density of 7.8 gram per cm cube. A hole of volume 2.1 cm cube is drilled into the cube. State the density of the iron cube after the hole is drilled. Okay, whether drill or cut in half, the proportional amount of mass and volume will be taken out. Okay, so it is just equal to the density of the block. Density equals to mass over volume. The mass is unknown. Okay, so density is just 7.8. I don't even need to do any calculation. Okay, it's just 1 mark. Even after I drill a hole, it will still be 7.8. I drill a bigger hole, it will still be 7.8. I drill an even bigger hole, it will still be 7.8. Okay, now the hole is then filled up with another metal which has a mass of 13 grams. So now the density will change. Okay, it's because it's another metal. So we calculate the total mass. How do you calculate total mass? Before that, what was the mass of the iron cube? Let me do a calculation. The density is no. Let me do the volume. Initial volume before the hole was drilled, initial volume was 3 cube, so it's 27. Okay, so now a hole of 2.1 cm cube is drilled. That means after hole was drilled, after volume will be 27 minus 2.1, so it is 24.9 cm cube. Okay, and then I can find the mass. So I'm doing the density equals mass over volume. Density is 7.8, volume is 24.9. The mass after the hole is drilled for the iron cube will be 7.8 times 24.9 will be 194.22 grams. Okay, so the total mass will then be 194.22 plus 13, so will be 207 3SF grams. Alright, hence calculate the density of this composite cube. The hole is filled up. That means now the volume actually went from 24.9 and back to 27 cm cube. So density equals to mass over volume, so equals to 207 over 27. Alright. Okay, now question 6, it shows 2 vertical tubes. Looks like a barometer, each closed at the upper end. The pressure in the space above the mercury in the tube P is negligible. So here, no pressure. There's a small amount of air in the space above. So I told you all, every time a liquid is subjected to a pressure, and of course we draw an arrow, and for those outside it is actually P atmospheric pressure. Here there's no pressure, so no need for arrow, but here there is air introduced, so I put it as P air. This P air is different from P ATM. Okay, density of mercury is 1.3 times 10 to the power of 3, 13.6 times 10 to the power of 3. Gravitational force on a mass of 1 kg is 10 Newton. Basically, it's just G equals to 10 over 1 kg, so it's 10 Newton per kg. Just trying to be funny, this question. By the way, I said this question. So determine the pressure in Pascal exerted by the air in the space above. So really, the first step is draw arrows downwards on surfaces that has pressure. That has pressure on it, acting on it. Okay, so we have done that. This is PATM, this is P air on these two surfaces. Okay, over here no need because it is vacuum. So over here is vacuum, negligible pressure. Second thing is to same liquid, same level, same pressure. Alright, same liquid, same level, same pressure. And according to all the dimensions, I should choose this level where we have the same liquid, same level, same pressure. So outside here, okay, is PATM. I use different color. So PATM is over here. How much is PATM? PATM, if you read from this, from P, from barometer P, it is 75 cm Hg. That means the height is 75 cm. The density that I'll be using is mercury, which is provided. And later on, if I were to calculate the pressure in Pascal, I will need to multiply by G, because don't forget, pressure equals to rho GH. Okay? But let's not do this first. We just keep it as PATM equals to 75 cm Hg. Now we look at barometer Q using a different color. Again, we have same liquid, same level, same pressure. Over here will be PATM. Okay? But over here, the pressure acting on this liquid is due to the height of mercury above here and also P air. So now I can form an equation. PATM, which is this, is equal to same liquid, same level, same pressure, the pressure of P air plus 60 cm of Hg. Now since PATM is 75 cm Hg, I should substitute it into here, right? This is what I get from barometer P equals to P air plus 60 cm Hg. That means my P air is 15 cm Hg. If you do your math, you subtract. Now I need to convert it into Pascal. So pressure equals to rho GH. So 15 cm Hg, okay, be careful. This 15 cm is my H. Hg is mercury's density 13600. In order to be in Pascal, everything has to be in SI unit. So what am I lacking? I'm lacking my G. So I need to have it as 10 Newton per kg. Okay, so now the problem is 15 cm. I need to convert it to meters. So equals to 0.15. So I multiply everything together. I will get 2.04 times 10 to the power of 4 Pascal. Okay, please try this. Now more mercury is added into a reservoir of mercury. Still, what happens to D1 and D2? Okay, D1 remains unchanged. Okay, D1 remains unchanged. D1 is actually this. It remains unchanged because you did not change atmospheric pressure. Okay, but D2 will be reduced. Okay, why is D2 reduced? Because if I have okay, so I'm trying to explain why D2 is reduced. Okay, so look at the green color. That was before I increase the height of the mercury in the reservoir. Okay, PATM is equals to this height plus P air. Okay, so this was the previous case. But now if I add in more mercury into the reservoir, this formula still stays. PATM equals to rho GH plus P air. It depends on the height of the mercury plus the pressure of air inside this part. But PATM remains the same. You cannot change PATM unless you go to another place. But all we did here was to increase the height of the mercury level, or more mercury in this reservoir. Yes? That means by right, this mercury should go higher up. But when it goes higher up, that means I am compressing my air. I'm compressing my air. So my air pressure is increased. My air pressure is increased. Why? Because there is lesser volume, space. We are compressing the air. So the pressure of air increases. Now PATM is constant. PATM is constant. We did not go to another place. PATM is the same. But when I give the air lesser volume, because now I added more mercury, lesser volume, the pressure of air will increase. The pressure of air will increase inside here. And if the pressure of air increase, that means my height will decrease. My height will decrease. Okay? So at first, the volume went up, the height went up because I added more mercury. But as it goes up, it squeezes the volume out from here. There's lesser volume, right? Air is compressed. But when air is compressed, the pressure of air will increase. Then if you look at this formula, PATM is flat, is fixed. My pressure of air increases. That means my H must decrease.